Okay. Yeah. Hello, everyone. Is my sound audible to everyone? Hello. Hello.
Yes, yes,
Oh,
coming,
oh,
coming.
okay. 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 Yeah. Welcome to the PCB design demo course. Okay. It's a demo for the PCB design course actually. Okay. So, what is a PCB design? Okay. Let me start with just an introduction. What is a PCB design? Okay. You are using electronic components, gadgets, mobile phone, TV, fridge, AC, everything in which all the things are the motherboard which is sitting inside that one, that is what called a green color. You have seen it in green color, blue color, red color, black color. This is what is called PCB. Okay. PCB board is nothing but a thin plastic board. Okay. A thin plastic board in the top of which copper is there. In that copper, etching is done, and then this PCB is been fabricated. Okay. Like I give you an example, a small example of that one. Okay. Give me 1 second. In paint, I am giving that example. Suppose this is a PCB, okay, a small PCB. In the top of this one, it is coated with copper, completely copper. It is coated the top of this one. Now in this one, we will be making. There are many machines. Okay, PCB printing machines are there. Those are done with CNC. Those are some rotating tool will be there. In that one, that files will be given. Those are called Gerber files, and those files will create the design over this PCB. Okay. Now I tell you, suppose small patches will be there. You have seen suppose like this kind of small patches will be there. Small patches will be there in that one. These designs which are there, it has been created using the CAD tool. Okay. These designs, and then these designs are been connected via these are connected via the terminals. Okay, the routing lines. And how this connection is made, this is a copper board where the copper is available. Okay, it is copper coated board. In this copper coated board, some CNC machine, sharp tool CNC machine will be drilling around that one. It will remove the rest copper, and see this black one. See, this is here is copper. Again, that black one means there is no copper. Again, the yellow is copper. Okay, means the overall thing, only the yellow part where it is there, it is being connected. That is copper. Wherever the black part, that is removing. That what removing that thing is the work of the PCB machine, PCB etching machine. Either it is done via laser or it done via sharp CNC tool, sharp object. Okay, this is how the PCB is created. Okay, now you have seen those things in your electronic gadgets. The work of that PCB is to connect those electronic components with each other so that those electronic component can function properly. Excuse me. In those electronic components, you might have seen integrated circuits, resistors, capacitors, inductors, some other couple of devices like diodes, some small ICs. So those ICs, inductor, capacitor, those components are connected, interlinked with each other. Okay. So to maintain a professional, the connection should not break at any cost. So if we take a IC, okay, if you take IC, suppose, and we connect one register, okay, we can take the IC, we can solder that register there also, okay, like this. If we go, if you are taking a IC, suppose, okay, if you are taking a IC, suppose if we are taking a small IC from at this end, suppose a small IC it is, okay, it is a small IC, okay, some terminals are there, okay, terminals are there. We can take one register. We can take one register like this also, and we can solder that register at this terminal, and it will suppose go to the VDD or the voltage line. Okay. One capacitor is there. Okay. We can also take that one and we can solder it with this one like this also. So does it look good? It doesn't look good, and it is much more prone to breakage if something happens. External force applies to that object. So suppose we are moving a refrigerator from shop to the home, there is a movement in that one. If that movement in that one, this thing can break also. So to avoid such disconnection and breakage, that's the reason why we put PCB. Okay, in that PCB you will see IC is given here, IC is there, then a capacitor will be here, then a resistor will be here. In between them, the connections will be completely made with thin wires. Okay, those are called tracks. Those are called metal routings, metal tracks. Okay, it will be like this. It will be connected properly. Okay, it will be connected here properly like this. It will be okay. So after that, what will happen? We will able to do the connections, and then it will be supplied to your system with a voltage, and your system will start working. This is what actually PCB design is. Okay. So what is PCB design? You got to know. Okay. So a plastic board
स्लाइड
or a
में
five.
विच स्लाइड
Hello.
में कौन से स्लाइड दिखा रहा हूँ स्लाइड तो एक ही दिखा रही है फर्स्ट वाली
ना ना, वो मैं अभी दिखा नहीं रहा, अभी दिखाऊंगा।
ओके
अब ठीक है।
हाँ अब सही है परफेक्ट
वो एक्चुअली कुछ ये नया वाला है ना, तो इसमें कुछ पता नहीं, सेटिंग्स चेंज हो गया शायद।
कोई नहीं है सही है ठीक है
हाँ, so this is what actually PCB design is called. Okay, PCB design is nothing but what if someone asks what is PCB design? A thin fiber board in which copper is coated, in which the tracks and patches are created. So that is what called PCB. So PCB can be single layer and up till it goes up till 32 layers. Okay. So generally in the industry grade, what you will see, the mobile phone ones are the heavy layer, number of 32 layer. But the initial what you actually see, those are generally small, only like one layer to 10 layers. Initial what fridge, TV, all sort of thing you see, those are like this. So laptop, mobile thing which is more complicated, those go up till higher number of layers. Okay. PCB is the land in which, or suppose you are after getting a big package job, you are purchasing a land, right? In that land you will be making your houses. So that land is what actually that PCB board is. In the top of that PCB board, a small designs are created. Those like you create, if you see your home from the top, from a flight, from a plane, okay, you will see over a brown or a green area, you will see small houses are there. If you see a PCB board from the top, it look like that only. It's like a small city. It's like a small city completely. A PCB board is a land, a green color land where the grasses are there. On the top of that one, some component, the component looks like a city if you see it from the top. Okay, in that one if you see, it is sometimes green color, sometimes it is black color, sometimes those are called UV coated, that is called. Okay, that is called the colors. Sometimes the colors are being changed depending upon the requirement. Okay, so this is the overall scenario of a PCB. Okay, PCB is usable in majority of the industries across the market. Okay, so the course overview which we are going to do is, we will do PCB designing starting from the basics. We will take care. Okay, we will do starting from the basics, and we will go further smoothly. Okay, in which PCB design workflow will be there. Schematic design we will do. We will do PCB layout. PCB design is divided two parts. First schematic design, then layout design. Then after that one DRC is done. After the DRC is done, we will go for the Gerber generation. Gerber files are the files which give the information of the layout, the small patches, the soldering, the shoulder patches, the drill legends. These all things, the drill holes, as well as the legends. Legends are the names which legend written on the top of that PCB. IC1, IC2, register R1, R2. These are called legends. Okay. So these all things are put in a Gerber file. Okay. So we will be studying all these things in the full course, and the manufacturing guidelines which is required to manufacture the PCB. There are multiple guidelines. Okay. So PCB design workflow. So concept and schematic design. What is the concept and what is the schematic design? How we do? component selection, which component we should take for which purpose, that we will do. We'll do PCB layout and routing. First, the floor planning we will do, in which we have to put the device in a very accurate manner so that it should be very optimized. And then the routing we will do. Okay. Then we will do prototyping and testing. We will do some PCB fabrication also, small fabrication also we will do. We cannot go for a higher number of fabrication, but small fabrication we will do. And then we will try to get it manufactured. Manufactured means we will try to do a basic manufacturing techniques, and we will see how the manufacturing happens in the industry also. Okay. So introduction to PCB design software. So see, there are multiple softwares in the market. Okay, you have heard about KiCad, Altium Designer, OrCAD, Eagle, Easy EDA. Then earlier it was used Proteus also. Proteus is for simulation also. Then Multisim is also one of the software used. So industry uses only three big softwares, either Altium Designer. The majority one which is used across throughout the industry is OrCAD or Allegro by Cadence. This is the most used tool in the industry. And one more use is EagleCAD. EagleCAD has a huge number of library. See, KiCad is open source. Many of them do this one, use this one. Many hobbyists and DIY guys, engineering students use, but it has some limitations also. Eagle is for them who want to start their PCB design understanding. So it has multiple libraries. It is industry grade tool. So if you want to go to higher level, you should go for OrCAD Allegro. That is the most used industry level tool in the market. Okay. It is made by Cadence. Okay. And some other small tools are also there. Fritzing is there. Many things. So these are the majority tools. We will be using, starting with first EagleCAD. We will give you the tool also, will provide you the tool, and then smoothly we'll go to OrCAD and Allegro. OrCAD and Allegro is a single tool only. Okay, we will go in that OrCAD and Allegro, and we will learn that is the only industry level tool we use in the market. Okay. Then we will be doing some schematic design basics, like symbols and connection. What are the symbol, for which symbol, what is the purpose? See, there are multiple things: resistor, capacitor, inductor, IC, SMDs are there, small mounted devices or surface mounted devices are there, SMD ICs are there. What you have seen in engineering class, those are bigger one. You, when you go to small level, it will become SMDs. Okay, we will see the SMDs. Then we will go for connectors. There are multiple type of connectors: screw terminal, male female jumpers are there. Okay, jumper blocks are there, many thing connectors. So we have to know each of the every symbols and their what kind of connection they hold. Okay, how to label the nets. So when you are routing, there should be label what net, what is the name of that net, what kind of power connection. See, there are many concepts also coming. Okay, IR drop is there, electromigration techniques are there. So this creates then crosstalk is there in PCB design. So many things will come across the layout, which will hamper your design, which will hamper the productivity of the output signal of the PCB. So we have to understand this physics completely. Okay. After that one, we'll go for layout essentials like a single layer, double layer, multi-layer PCBs. When we'll go for more and more layers. Okay, we'll do component placement strategies, many things we will take care. Then the design rules, we will look around how to trace what is the width and spacing, how, which thickness of wire you should need for what current. If suppose a current is holding this much, like a one amps, or just example was 1 amp suppose. Okay, so what is the thickness of that wire, that metal track should be. Then via selections, like suppose track one, so layer one, like metal one to metal two. If we are going the track selection, we will do. Then how to do high speed signal consideration, how to do that one. So these things we will take care on that one. We will do the simulations of the DRC. We will do signal integrity analysis and thermal and power, because these things are mandatory checkups for the PCB design. Okay, then we will go for at last Jarbal file generation, PCB prototyping and fabrication, and we will try some assembly and testing for small PCBs. Okay. So now this is the overall scenario of the PCB, what we will looking throughout the course. I will show you the syllabus also. Now, as a designer, PCB designer, Okay, one designer makes some mistakes also, okay, like poor commonplace component placement, incorrect trace widths, over complicated routing also happen, ignoring thermal management. Many things can come into picture. Don't worry for that one. We will do that one. We will teach you how to do all those things, okay? Then we will do a hands-on demo. We will go across the many things, many software, the tools. We will do simple projects to the advanced level project. We will go for many things. We will look around. Then what you will get from this course? From this course, you will get learn industry standard practice. What are the protocols in the industry? You will get hands-on experience. We will prepare you for real world PCB design projects. We will design a at a severe level, a complicated level PCB to get know how the PCB thing works. Okay. And after the last but not least, so we will go understand the whole scenario. Okay. Now I will show you the syllabus, what we will going to cover across the next 5 months. Okay. So first we will start with fundamental of electronics, atomic structure, current, voltage, resistance, Ohm's law. Okay. And we will do some small, every topic has projects, small to big. Okay. Voltage divider and circuit design. We will do some small things. Then we will go for active components. We will first understand what is circuit design, basic. Then we will design those circuits. Then we will go for advanced level topics of PCB and we will do the layouts. Okay. See, we will do component, active component, then circuit analysis, nodal analysis, transient and steady state response, these all things. Then we will come to digital electronics. We will understand the digital electronics basic. Then PCB basics we will go. We will make some projects also. Okay, so projects will be this only. You can see the projects. The projects we will be working on this one only. Some changes can happen later depending upon the requirement. Okay, then what are the basics of a schematic design? Then what is PCB layout actually? Then what are the manufacturing and fabrication steps? What are Gerber files? What is integrity check? What is PDN power delivery network? What is there? See, many things are comes into picture. So those things we need to check actually. Okay. So what is multi-layer PCB? What is high-speed PCB design? Okay. Then we will go for RF design. RF design requires a very crucial checks. Okay, like Wi-Fi antenna, these all things need to be done on the PCB only. So we have to design them also. Okay. Then we will do heat management, heat sink. You have seen over the IC, a metal block is there that is called heat sink. It reduce the heat of that IC, the heat getting dissipated over the IC, that it actually reduce over using that heat sink. You will see in your computer CPU, you have seen those things like a fan is there. Okay, some cooling is there. So those are actually reducing, those are heat sinks actually. Then we will do PCB testing. Then we will do how PCB is being tested properly. Okay, what the output we are getting. Then we will do manufacturing, understand the manufacturing guidelines. What are the DFT in circuit testing? Like when circuits are there, we create test points. Okay, we will understand how those test points are created. This is called design for testability. This is called. Okay, and industry standard ROHS compliance and major projects we will go for. We will create a microcontroller based system, PCB design, and we will export it Gerber files and we'll look around how it is going to happen. Okay. And we will do some manufacturing, the small manufacturing. This is the overall thing in next 5 months we are going to cover in this PCB design course. After this course, you will be able to design a PCB of at least 2+ years of experience you will gain after this course, and you will get to know in details of the PCB design, and you will be familiar and you will able to create many things in this PCB. You can create your, suppose you want to create a small thing in your home or in your college project, or you want to see college project already have PCB, to you do solderings, right? You guys do solderings in PCB. Why do you go for solderings? You can create a PCB. You can create a PCB, and those PCB you can submit in that college. First, draw the circuit, analyze the circuit, it's working, create a PCB, fabricate, easy fabrication, I will tell you, in your home, fabricate it, and then submit to the professor. Professor will be impressed and he will be getting a higher outstanding marks. in industry level, when you are going for industry level, the salary of a PCB designer starts a minimum of 5 lakhs and above. Okay, so 5 lakhs and above the PCB design for a big companies, 5 lakhs and above it will start. Okay, so if you're going for a big service-based company like HCL Technologies or any other companies like Capgemini, they pay you a good enough, a handsome salary of 5 plus LPA. If you're going for a product company, they will pay you more. And there is a huge demand in India for PCB design. HCL government is also providing tons of funds for creating PCB industries. Okay, so till now we used to outsource the designs to China, and we used to import the pre-built PCB from China. Now government is giving the subsidies to create PCB designs and manufacture it in India. Okay, so PCB design has a huge market. So take this course seriously and build your future in PCB design. Okay, now we will go to a design and we will design one small design. Okay, in of a PCB. Okay, let's do. We will do it in Eagle. Okay, I have already done one of the thing, so I will close it for now. I will close it for now. Okay, I will close it for now here. I will just close it for now completely. See, this is our Eagle tool, environment, Eagle environment. First step, we'll go to files, new, and schematic. See, this is the schematic window, what we have. Okay, we will get the tool, we will get the OrCAD and Allegro also, we will get the schematic also, this Eagle also. Okay, Eagle tool also. First, we will come across this one. Okay, someone having any questions? Okay, so this tool, in this tool, first we will come and see there are multiple options here to add part, to delete, settings, move, flip, rotate. Many things are there. So general one we will see. We will go to the add parts. Okay, we will click here. We will come across this one. Okay, we will type here voltage regulator. Voltage regulator and enter. If I do have voltage regulator, I will able to see multiple voltage regulators are there. Okay. We'll able to see multiple voltage regulators are there. This kind of designs, what it is called, these are SMD designs, surface mounted devices. Okay. If you come across this kind of design, these are the actual one, the normal one. These are the normal version. This has multiple footprint, the packagings. So packaging you should be knowing. So this is TO220 packaging. So it is TO packaging. Okay. So we will tell you DIP, dual inline package, BGA, ball grid array. So these are the packaging styles. Okay. Then we can go for this one. We can go for this design also. Either we can go for this kind of I think so we can go for this one also, if I'm not wrong. Okay, this one also we can give. This is the most important one to use. We can use here. Okay, we'll put here one voltage regulator. Okay, then we will go for a capacitor. We will take the, or we'll take a capacitor. We'll take capacitor from here. Okay, we'll take a capacitor from here. We want a big capacitor, so we need this one. Okay, so we will take one, two, and three capacitors here. Then we will go for diodes. Okay, diodes we will go here. Okay, we will go for our diodes here. We will go for diodes. Okay, we will go for diodes here. Let me get the diodes from this end. Two sets of diode I need. I don't know why it is not giving me the diode. Sorry, diode. Okay, now it should be okay. Now this one. Okay, so we are making a 7805 voltage regulator. Okay, one, two, three, and four I will take care. Okay, and AW screw. Okay. What we are doing here is we are interested to put one here and put one here. Why I am telling you? This is because the transformer input will come from here and the output of the circuit will go out from here. Okay. So we are not putting the transformer at this place. Give me 1 second, please. Yeah. So the transformers we are not putting in this one here. The transformer input will be here from here and the output will go out from here. Okay. So we will be doing it in this way. Now what we will do here is we will come across this one and we will be routing. Okay. Now Alt N used to draw the terminals from here to here. Okay. Okay. So net, we will be drawing like this. We will be drawing the net connections from here to here. Okay. Just see, we are drawing the net connections from here to here. Now, what we will be doing? Okay. We will be coming across this end. We will be adding it like this. Okay. Then again, we will be connecting, holding this guy, and we will adding it here. Okay. Then we will be taking this guy and we will connecting it here simply. Then again, we will be taking this one from here and we will come up till this end and we will just connect it like this. Okay. All got connected. Now we will connect it like this here. This should get connected up till, sorry, this should get connected up till here. And from here onwards, I will just flip this one for now. I will just flip this guy from for now. Okay. Okay, I will just flip it for now. I will just go to draw and net. Okay. I will just add it from here to here. Again, I will add this one from here to here. It got connected. Now, this is the transformer input we will take here and we will connect it. Okay. And then we will just short it up till this end. Okay. Now, if you see, our schematic is ready completely. Our schematic is completely ready here. Okay. You see our schematic is ready for a 7805 voltage regulator, 3 capacitors, 4 diodes, one 7805 IC, and two screw terminals. Those green color terminals you have seen using the nut. Okay. Wait, let me show you. Screw terminal. A screw terminal block. Okay. Screw terminal. This one is called as screw terminal. This green one. Okay. So it is the most like strong term. It is very strong terminal. Okay. For input output. So we will be using, after this is done, we will simply go to SCH2 board. We will switch to layout. This is schematic. Now we'll switch to layout part. Okay. And we'll save it. See, now I am here. This black one is my PCB board. I can decrease it. I can increase it, whatever I want to do. Now what I will be doing, I will be taking this guy from this end. Okay, I will be taking this diode 1, diode 2, everything I will take from here. Okay, then what I will do, whenever you want to check wherever I want to go, you will just switch back to schematic and board like this. This is X1 is the input, X2 is the output. So what I will do here is I will take this guy. Okay, I will take this up till here and I will just rotate it for now. Okay, I will just rotate it for now. Simply, I will rotate it and I will keep this one at this end simply. Okay, now I will take this diode 1, then diode 2. What is our diode 2 here? Is our diode 2 here. Diode 2, I will keep it here. Then I will take diode 3. Okay, diode 3, I will take it from here. And then at last the diode 4. Okay, Now what I will do, see the connection, it is, this is, this yellow are for the fly lines, okay? See, this, it is, the wire is coming from this end. So what I will do for now, I will just flip this guy, this diode to this end. So it will become straight. And this also I will flip like. So it will become easy for me to work around. Okay. Then what I will do, I will go to the capacitors now. Okay. C1, C2, like this I will go. So we have to give some space. Okay. C1, okay, C2, C3, and the last one is, of course, C3. Three are there, so we can adjust it like this here. This end, we can put it somewhere here. Okay, now if you look around it, we see, we can just make a distance. Okay, so ample of distance to put big capacitors. Okay, otherwise you will face lot of issue to keep the capacitors there. Okay, so that's the reason we have to put it like this. Or you can make some more couple of space to, for a safe side. Okay, give me 1 second. Okay, okay. Now this guy, okay, this guy, this is the register IC I will take, and I will rotate it for now. Okay, I will just rotate it on, and I will, what I will do, I will keep it around this end. Okay, excuse me, and I will just try to make this space minimum, so that, okay, this IC will come around this place. Okay, and last, I will take this terminal block from here to here, and I will put it here. Okay, and what I will do, I will just put this one simply at this end. Okay, okay, I will just put this one at simply at this end, or I will just figure it out. Okay, like this, and what I will do, okay, I want to move it. Okay, simply I will move it like this way. Okay, now what I will try to do here is, I will just look, okay, this is coming a bit outside. So what I can do here is, I can just make it directly smooth inside this part, so that it looks perfect now. Okay, so what I can do here is, okay, we can decrease this space, because diode doesn't require that much of space to be taken care. Okay, okay, what we can do here is, what we can do here is, we can make this space little bit. Okay, now it is fine for us. Now what we can do here is, we can bring this uh, terminal, this PCB board, we can squeeze it, this we can squeeze this PCB board up till here. We can squeeze this PCB board up till here, this end, and then will some space we can keep here, and then at last we will drag it up till this end. Simple, simple. We will drag it up till this end, and we will leave it. Okay. Now, if you see this one, you will able to see. So, okay. So now if I come across this one and try to, okay, it is fine. So now see, this is the overall area in which I have to do this routing of this PCB. Okay. You can use this auto router also. So auto router also we can use. We can have to do the settings here. Okay. So auto router is also there. We can use it. Okay. So high also we can do. So many things we can do. We can do some editings also. We can go many things we can do. So auto router, if you use here and continue, it will do the auto routing everything from here, and if you click on start, it will do the auto routing automatically. But it is not fixed that it will be using that same thing only or not. Okay, it is not fixed that it is, see, it is taking red one is the, so this is now become two layers. Metal, this blue one is the metal one which is coming in the top, this red one is the uh, metal 2 which is coming below side. Okay, so it is becoming a dual layer PCB. Okay, so if you don't want to creating multiple layer will increase your price, but we are not into this one to create. We want to make it we want to squeeze it. Okay, we want to squeeze the cost because this PCB can be done in single layer itself only. So what we will do, we will remove this. We will take this option route wire and we'll do manual routing. Okay, we will make it like this. We will go to the width. We will take around 40 width and we will start routing it. Okay. Okay. So we want, okay. So the red one is the top, okay, top layer 16. This is the bottom layer. Okay. What we can do here is, okay, let me take the red one. Okay. Sorry for the color confusion. Red one is the top color, blue is the bottom one. Okay. We will click on routing this one. Okay. So see, the routing becomes easy at this moment. Then, okay. So what we can do here is we can route it from this end. Okay. Okay. So what we can do here is we can connect it like this at this end. And then we can take this guy and we can connect it like this. Okay. Done here. Now what we will do here is we can connect this guy from here to here. Actually, it should be flipped. Okay. But I don't know why it is not flipping like this. It should actually get flipped at this end. Okay. Otherwise, the routing will be easier on that case. If it get flips, give me 1 second. Please give me 1 second. I will just flip this one and I will try. Okay. But it will not get flipped actually. It will not get actually flipped. Okay. So what we can do here is either we can go and create it like this. Done. And then this guy, what we can do here is we can go, sorry, like this we will go, like this we will go and we will connect it like this here. Okay. Now coming to this end, we have to first, okay, sorry, like we have to connect this one. This guy first we have to connect here and it will go and connect at this end also. Okay. Now, if you see this guy, it is being connected up till this end all. Okay. Now, if you look around this one, this also need to be connected at this end, right? So first, what I will do, I will take this guy and I will connect it up till here. Done. This point need to be connected here. So this point most common I can see here, but if I drag it from here, it will be difficult, I guess. I guess it will be difficult, right? I need to connect it at somehow at this end. Either I can do it from below or I can do it from, so the top one, I guess, is the most usable what I can do here. Okay. Now what I can do here is I will just make it proper like this. Okay. It will be easy for me. Then what I will do here from here, I want to drag this guy. Okay. Okay, but the things are not good actually. What I can do here is what I will do, I will connect it like this first. Okay. And this one requires a connection up till here. Okay. Better I will do, I will take this guy from here. Okay. And what I will do, if some place you want less routing, thin routing, you can change this one to thin and you can route it. Okay. But I don't think so it's required here. We can go up with this one and we can just route it at this level. Okay. We can route it at this level and the whole connection seems to be fine. And then this will go to the ground connection completely. Okay, this will go to ground connection and this will become straight. Okay. And if you see now, all the connections are completely done here. All the connections are completely done here. Okay. See, all the connections are manually are done. So thick widths are thicker now. Everything is it looks very good and clean. We can just drag it this one. Okay. It's not good. We cannot drag it more. So what we can do here is, okay, it is, so let be the space this much only. It is okay. So now if you see the input comes from this side, the voltage, if the 12-volt input is there, the AC input from transformer, it will be uh, step down due to the 7805 combination, and this output will come out. Okay. Here the AC to DC conversion will happen, and then it will go to 7805, and the output will come, a stable 5-volt output will come from this end. Okay. So this is how you can create a circuit or the layout. Okay. Now you have to go to tools, DRC, and check. If the errors are there, it will highlight there. If the errors are not there, it will highlight. Okay, DRC no error. Just see DRC no errors are there. So there is no error for the DRC. After this, all things are done. If you want to make the 3D model of this PCB, you can go. So you want to like visualize, you want to do something. So you can go to Fusion 360 by clicking on here. Because I don't at this moment, I don't have the Fusion 360 installed in my system. Once the code start, I will install the PC Fusion 360 and I will show you that thing also. It's very nice to visualize the things in the Fusion 360. We can just see this PCB board. We can put the components there, and we can create a furnished PCB 3D model, and we can use it. Okay. So this is the design, general design. After this is done, you can save it, and then you can generate CAM data. Okay. You can generate a CAM data, and then, okay, just let me save it somewhere. Okay, let me save it somewhere. Okay, BRD. Okay, I will just create it as BRD. Okay, and open. I will save it here. After this one, see, it will generate the bottom data, top data, then everything. Solder paste. See the names. Just see. This Gerber is this top one. Okay, this top one will give the information of this red color because we have top metal. We don't have the bottom. So bottom is useless. Bottom will have nothing. So top one will have this connection. So top one will be using, then solder masks. So what are the solder masks? Where are the solder masks need to be put there? So solder paste, where to put that one? Silk screen, that green color, red color, those things are that called silk screen. Okay. After then the drill files, how where to put the drills using drill work. Then the assembly, how the components will be assembled. In the because when the product come from the factory, the components also are assembled. That option is also there. Okay. It's all things will be there and it will generate the data at this level. Okay. See, and okay, save. If I save it, see, when I come across this one, see, schematic and board got saved. If I come across this one, you will see all the assembly files where you want to assembly, drill files where the drill is required, the Gerber file. See, all the files are available in this one. See, just all the file. You can use Gerber viewer to view all these things. Okay, all these things you can view it. Okay, so this is how we do the complete PCB design and PCB fabrication. These all things we will come across the next 4 to 5 months, and we will understand the whole PCB fabrication, PCB design, everything we will take care. Okay. So now, if you guys have any questions, you can ask me. Any questions, you guys, you can ask me. Okay. Ready to this one. Hello. If anyone having questions related to anything related to PCB, any tools, you can ask me. I will try help. Happy to discuss with you guys. See, there are multiple reference book across the industry. Okay, so there are multiple reference book for PCB design. So you can refer any of the book, but we will also give you materials to study. So don't worry for that. Once the course start, we will give you the details of the PCB materials, which will be helpful for you to understand the things. Okay, there are many books across the industry to read. So any questions you have, you can ask me, guys. Hello. Hello, guys. Any questions? You can ask me. So this is how we are going to understand the PCB starting from basic schematic to the layout one. the guys who are looking to join the core industry, PCB industry, PCB design, these are the core domains. Okay. Interested guys who are studying in college, who are professional, want to switch to this domain, are most welcome to understand this whole scenario. Okay. So this is all we are going to do in this next few months. Okay. If there is no question, then we can end this demo class session today, and we will meet in the actual class, which Rajat will discuss. Okay. The cost of the course you can
Then
ask
WhatsApp,
Rajat.
WhatsApp। वो सिलेबस बता दिया, सिलेबस पूरा।
हाँ,
और
सिलेबस पूरा बताया ना।
ठीक है, ठीक, ओके।
सिलेबस
प्रोजेक्ट्स
पूरा
बताए,
उनको
प्रोजेक्ट,
दिखाया।
प्रोजेक्ट्स।
हाँ, प्रोजेक्ट्स भी मैं डिस्कस कर दिया हूँ उस पे।
ओके, ओके, फाइन, फाइन। ओके देन, थैंक यू एवरीवन, थैंक यू,
I
थैंक
have told them that projects will be actually
यू। यस,
that
यस।
microcontroller board design we will be do
It
at the
will be
end.
basic to the advanced, very advanced. They will go to the very advanced level. Yeah. Okay, fine.
See, give me 1 second. I have told them that each and every topics will have small projects, and at the end we will be creating a big microcontroller based
Hmm.
project that I have discussed with them once,
Great. Okay, fine.
and I have shown them a PCB design also here.
Okay, okay, fine, fine. Anyone have any doubt, or we can end the session? Okay, so we can end the session now. Okay,
You
fine,
can
fine.
ask Rajat for further details.
Okay, fine. Thank you, everyone. Thank you.
Okay,
So
everyone, then
Monday
bye.
we will start. Monday onwards we will start the batch. Yeah, fine. Thank you, everyone. Thank you.
Okay, everyone, bye and good
Bye.
night.